So as Tim introduced, I'm Abena, and I worked on this project during my master's capstone at Southern University and A&M College. And I was curious about how deep neural network can be used together with PlanetScope satellite image to monitor urban forests. And I chose Baton Rouge because that was where I lived, so I wanted to conduct a research on that. And so a quick background, research shows that now over half of the world's population live in cities. And we love to be in cities because we feel there are lots of resources there, good facilities, good schools, lots of job opportunities. And so we want to hop on and live in the cities. And it's also stipulated that by 2050, 2/3 of the population will be living in urban areas. And this poses a lot of stress or pressure on green infrastructure within the urban areas. It's also noted that cities are responsible for estimating or emitting about 75% of carbon dioxide globally. And we know that carbon dioxide is a heat-trapping gas that causes a lot of heat into the atmosphere and then also causes global warming. And this also affects climate change. However, urban forests can be used as a nature-based solution to help reduce the effects of climate change. Now, let's have a quick definition of urban forestry. Urban forestry is also known as green infrastructure. So wherever you see green infrastructure, that's specifically what we are referring to. So urban forestry deals with the art, science, and technology of managing trees and green spaces in and around our communities for their physiological, aesthetic, economic, and sociological benefits. So some of the benefits of urban forestry in our ecosystem would include improving our air quality. So the trees in our areas, the urban areas, has the potential of filtering the air we breathe. So like we have particulate matter, PM2.5, PM10, and other harmful gases in the atmosphere. The trees and the leaves are able to filter the air we breathe so that we have good health. And then there's also microclimate regulation in the sense that because there is shade and there is enough trees in the environment, it's able to reduce the temperature of the environment such that we have some cool breeze also as well in the environment. And then the trees are able to intercept direct rainfall such that it doesn't hit on impervious surfaces and flow to cause flooding. Another thing too is that because of the trees, they're really able to seep into the ground and then can serve as more water for the trees. There's also carbon sequestration, and then there's also the urban forestry serves as habitat for biodiversity. So we have like some bird species, like some butterflies and other species who live within these urban forestry areas. And then also urban forestry promotes our physical and our mental well-being. So for those of us who are interested in exploring the benefits of urban forestry related to mental health well-being, there's a research by Melissa Marcel, and then she says that urban forestry can reduce the rate at which we use antidepressants. So you could just check out that article. And so based on all these benefits of urban forestry, it's very necessary to monitor and protect our urban forests. Now let's look at some examples of urban forests in our environment. We have urban gardens, so like these urban gardens that have herbs or rose flowers and things like that is an example of an urban forest. We also have the trees in the cemeteries. It's also an example of an urban forest. And then we have the street trees. That's also a category of that. We also have this vertical forest or green walls, which was initiated by Stefano Boeri in Milan. So you could check out more of that. We also have urban agriculture. So like planting, eating what you plant. Yeah. And then we also have green roofs. So like there's space on the rooftops and the people can also have some green infrastructure there. And then lastly, we have the urban parks. So these are some of the categories of urban forests. I'm sure we have so many of them around, but it's because some of us are not very familiar or aware, we might not even see them as urban or green infrastructure. All right, so now let's look at the problem. We know that urban forests are prone to fragmentation resulting from urbanization, as we said, movement of people from one point to the other. And then there's also natural disturbances. So in the event of a flash flood or hurricane, it makes the urban forest susceptible. And then also anthropogenic activities can also make the urban forest susceptible. All right, and then when there's a temperature rise resulting from the climate change, it can affect the physiological functions of trees. And this was one thing I learned from my ecophysiology class in school, that just as humans go through heat stress and heat stroke and things like that, the leaves also go through a lot of physiological stress. And an example is that the leaves can overheat, and then that can affect the cellular processes. So like respiration, photosynthesis, and food preparation can all be altered just because there's a high rise in temperature. Also, invasive species such as the emerald ash borer or the Asian longhorn beetle can be a great threat to the urban forest, and then that can also affect their major role in the ecosystem. So currently, there is no time series data of Baton Rouge urban forest cover, and so that can also affect the efficient management of the city's urban forest. And I was curious about that, and I was just thinking, like, how do we know how much urban forest cover we are losing when we have all these drivers within the ecosystem? So this is just some few pictures I put together showing some strong wind activity that can affect the urban forest as well as other damages. And then same as a flash flood event and invasive species. There's one thing too I learned in school that talks about planting the right tree in the right place. And so like if you plant a pine tree, the pine tree can really grow very, very high. And a pine tree doesn't have the capacity to withstand strong winds. So in the event of a strong wind, it can just fall off and destroy your building property. So you also need to know where exactly to plant what type of tree so that it doesn't affect or damage your property. All right, so let's look at the main objective. My main objective was to use a deep neural network together with PlanetScope's high resolution data to map the changes in urban forest cover for Baton Rouge. So I was looking at 2018, 2020, and 2022. And definitely we know AI has come to stay because it's efficient and helps us to identify changes that are going on in the landscape or in the environment. And so the deep neural network or neural networks in general was inspired by how the brain and the neural system has been set up, in the sense that like when you step on a pin or maybe a snake bites you, the signal is sent through the electrical impulses to your brain to let you know that you are in pain or something, and then the brain sends the impulses back to maybe like your feet, which is on the pin, and then you can just take your feet off it. So there's formula like input and then output in that setting, and then that same idea has been transferred into neural networks. So there's an input layer, there's a hidden layer which is similar to the transmission or the electrical impulses, and then there's also an output layer. So it looks a bit complex, but I think it's interesting when you dive deeper into it. So let's look at my study area. As mentioned, my focus area was Baton Rouge, and in Baton Rouge we have two universities, the Southern University where I schooled and Louisiana State University. And then there's also lots of brick parks and then some botanic gardens. There's also the airport, state capital, and then the Exxon Mobil refinery. My favorite spot was Louisiana State University because there are lots of live oaks in the school, like where the live oaks were planted and how the school has been planned was very nice. And sometimes when I'm overwhelmed with schoolwork, I just go find myself somewhere sitting under some of the live oaks just to recuperate and just recover, because school can be really, really overwhelming sometimes. So yeah, the population is about 222 according to the US 2021 Census Bureau. And research shows that agriculture and forestry generates about $10 billion annually for the state's economy. All right, so let's look at the methodology I used for this whole research. I had to collect training samples, and I did this in Google Earth Pro. I sampled about over 4,000 points in Google Earth Pro, so like urban forest areas and non-urban forest areas. And then I imported these points into Google Earth Engine to save them as assets. I know there's a possibility of getting PlanetScope images in Google Earth Engine, but for some reason I wasn't able to. So I had to go to the Planet website to download the Planet images for May 2018, May 2020, and then May 2022. I chose May because I was in this project in June, and so I decided to just focus on May. And then I checked the other months for the respective years, and I didn't really get a very cloud-free image, so I decided to just focus on May 2018, 2020, and 2022. And then, so I can move these things into the Google Colab, which is more like the virtual machine platform where I can create the model, train the model, evaluate the model. And then I also stored the DNN model in the Google Cloud AI platform for prediction in Google Earth Engine. So this is like a short summary of the methodology I use for my research. Okay. So this is just some pictures showing how I collected the data points in Google Earth Pro. So the NF stands for non-forest. So like non-urban forest areas that included water, roads, built-up areas. And then the urban forest areas, as you can see in the image on the right, included my trees, like street trees, urban parks, trees in cemeteries, and things like that, as I said in the earlier slides. Okay, so the image on the left shows a spatial distribution of the sampled points I captured. You can see that it's quite evenly distributed across the study area. And the image on the right shows a 4-band PlanetScope image for May 2022. So this is just a short diagram or a short picture that shows the structure of the model and how everything was done in Google Colab. So I had my inputs feature, so like for each of the points, I had a red, green, blue, near infrared, and a label to show whether it's a forest or non-forest label. So I had this going into this model, which is a simple DNN model, with a ReLU activation function and then a softmax. And then also the Adam optimizer. So all these things I'm mentioning are the model hyperparameters that must be tuned or fine-tuned so that you can get a good output. And so the final output shows an urban or non-urban forest probability map. Yeah. And so before I moved the sample data into the model, I splitted the data into training, which is 70%, testing, which is 20%, and validation, which is 10%. Yeah, so I'll just take you through my results. One thing I did was I set a threshold for urban and non-urban forest. So all values, pixel values that were greater than 0.3 was classified as urban forest, and those that were less than or equal to 0.3 are classified as non-urban forest. So I'll just play this short video to see the predicted against the PlanetScope image. Okay, let me just play this video again. So the green areas are the predicted urban forest areas, and then the gray areas are the non-urban forest areas. And as you can see, this was quite a good prediction. For the test metrics, I had an accuracy of 0.85 and an F1 score of 0.66. Okay, so this is just a time series that shows the changes for, this is I think the downtown area of Baton Rouge. So you can see that there's a couple of changes that has happened in the landscape. Yeah, and I use PlanetScope because it has a resolution of, this had a resolution of 4.7, and so it's able to tell some changes as against other low or medium resolution satellite imagery. So this is just a summary of the changes identified in the land cover. In 2018, the urban forest had a cover of close to 60%. And then in 2020, it had reduced to about 52%. And then by 2022, it has also reduced to about 50%. And then similarly, if we look at the non-urban forest areas, in 2018 it was about 41%, but it increased to about 48% in 2020, and then has also increased to like 50% in 2022. So this is just confirming or just letting us know that gradually we are losing our urban forest areas to the grey infrastructure. So just to conclude, I just want to reiterate that the study confirmed that a lot of changes has occurred in Baton Rouge, especially regarding urban forest cover, and that DNN models can be used to categorize complex landscapes, reveal patterns, trends, and then temporal differences. Also, PlanetScope is a very good satellite image for spatiotemporal analysis because of its high pixel resolution. And then based on my findings, Baton Rouge has lost about 9.9% of its urban forest cover since 2018. So further analysis or further studies can be done to investigate or find out the main drivers of this change in the forest cover. And results from this analysis can support decision making and so that we can head towards a sustainable city. And then I also want to say that even as we have it in mind to fulfill or focus on these SDGs, we have to be able to pay attention to the urban forest so that we can fulfill the SDG 3, which talks about good health and well-being, SDG 11, which talks about sustainable cities, SDG 13, which talks about climate action, SDG 15, which looks at life on land or the biodiversity and well-being improvement. So we really have to pay attention to our urban forest so that we can achieve all these sustainable development goals. For future work, I would want to incorporate other indices such as the NDWI to improve the model's accuracy. And then I'm also curious about estimating the carbon storage potential of the urban green cover we have in Baton Rouge. And then further, I want to predict the extent of the urban forest cover for 2030 and then see how best we can plan towards such realistic changes. So as I end, I want to thank the Severe TensorFlow team for organizing the TensorFlow technical exchange in 2019. As I sat during that workshop, I was very overwhelmed with so many things, but here I am today presenting some results based on some things I was taught there. I would want to say that the resources from that workshop was very, very useful. And then I also want to thank Tim and his team for giving me the opportunity to present my findings today. These are some of my references, and this is my contact information in case you want to reach out for more ideas or want us to discuss things related to urban forestry and then this geospatial. I'm available. That's my details on Twitter, LinkedIn, my email address. I also recently put together a blog that is addressing why urban forestry matters on Rezo platform. So feel free to dive into it and let's keep chatting. So yeah, that's Abena, as I'm currently a faculty assistant at NASA Harvest and a Google developer expert. So I want to thank you all for your audience and attention. And I'm available for your questions. Thank you.
Yeah, that was wonderful. Thank you so much.
Thank you.
Really, really wonderful. I can already see it. There's applause echoing in, and I see hands up already. I have like a huge list of questions. This is great. So let's just go right into it. Let's see here. Who is up first? I just saw a hand pop up. Let's go to Siddharth. I think you might be frozen. Siddharth, are you there? Can you hear us, Siddharth? I can see you moving now. Okay, good.
Can you hear me now?
Yes, yeah.
Oh, so some technical issues. That was a very nice presentation.
Thank you.
And I was like, I really like that Twitter handle here. Twitter handle, Miss_Pixels.
Thank you.
So, yeah, I just had a question which could be answered by anyone, I guess. For example, in recent times, we are having a lot of vertical plantation, right? On the buildings you are planting, people are doing green plantation vertically. And it's actually, if it's on the front side, it won't be captured by the images, right? It will be only the roof which will be captured by the images. And the vertical plantation has a good amount on the sides. So is there any technique or something by which you could estimate that in your urban forest cover? Because that would be a significant number in future, as there will be no space on the surface.
Yeah, and I think that probably LiDAR or maybe a drone technology will be able to capture that kind of representation on the building compared to like a 2D satellite image. Yeah.
Okay, thanks.
Sure.
Technology question. I'd almost imagine like SAR, vertical structure. Who knows though, right?
Yeah.
You need a lot of those buildings to create that signal. That's an interesting question though, because that is the future.
Yeah.
Well, wonderful.
I was just curious because of the resolution would be so much different, right?
Exactly.
Yeah.
It's a very unique signal. Great question. I'm going to read out Dr. Yang's question. Dr. Yang, feel free to correct me if I'm getting this wrong. So I saw the accuracy is much higher than the F1 score based on your experience. Could you briefly explain what is the possible reason for that?
Let me see.
Thank you, Tim, for having me mention my question.
Of course, yeah.
So the accuracy was about, let me see, the accuracy was 0.85 and then the F1 score was 0.66. Well, I might not be able to explain that so much into details, but I know that the F1 score takes into consideration like the true positive, true negative, false positive, false negative. I don't know if there should be, like in all instances, the F1 score and accuracy should be the same. Tim, what do you think, since you are the ML expert?
Dr. Yang.
So, normally, based on my experience, correct me if I'm wrong here. So, if the F1 score is a little much lower than the accuracy, that maybe indicates there is some slight overfitting or something in that model. So maybe you can try around I think the portion you mentioned, you have 70% for the training, 20 for testing, and then 10% for validation. That's great ratio. But maybe, I don't know, could you go back to the slides for the training sampling? Maybe.
Yes. Let me go there. Let me share my screen and go back there.
Thank you.
Thank you too. Training sample. Yeah, here.
Yeah. So because this year I don't know the details, but maybe because the urban forest, like you mentioned, urban examples, there can be a lot of species, and the text depends on the input remote sensing images. They could be very a lot, that color spectrum. Okay. So maybe they do the training, maybe the data. So after maybe in the future. For the input training data, you can balance the training samples. So that may be because in the training you have a lot of some type of thing. Then, but for the testing, right? Because you randomly select the training samples. Yeah. Maybe the training is not balanced. Then that's why when you do the testing, some of these things is not maybe not appear in your training data. That it's just my guess.
Okay. I'll look into that. Thank you so much.
Great.
Yeah,
thank you for a great talk. Yeah.
That's very inspiring. I was almost thinking maybe like a K-fold approach or something also to sort of look at the qualities of the data, sort of what you're driving at, Li Ping, of, maybe there's something that's inherently biased with a few of those samples that's really weighting down your F1. But, I mean, with a high accuracy, just from the visual inspection you provided, it looks pretty good. It's just that statistic is interesting. Okay, any other question? I saw some hands fly up, but then I kind of jumped between screens. So, Kristen, I thought I saw you join the call. Let me see if she's still here. Mickey's there too. Let's go over to Mickey.
Hey, great presentation. I had a question about when you showed the visual. It looked like your model was really good at picking out those really complex patterns that are kind of unique to those urban forests. So I was wondering if the deep neural network, I was wondering about the choice of your model and if you like experimented with other models and if you found that the DNN was better in this case.
Okay, thanks for the question. So I didn't experiment with other models. Yeah, I just focused on the deep neural network based on my experience in the 2019 TensorFlow technical exchange. So I could also look into that and see its performance with other model structure. Yeah, thank you.
Thanks.
Thank you.
I had a similar question on that front of, what kind of parameterization or different models or architecture or settings did you play with? But I think you kind of sort of drove at that already. Are you seeing, I know maybe to Li Ping's kind of last question about that 85% accuracy and that how it looks so nice already just from those visual use cases that you went in on. Are there any kind of classes that you're expecting this confusion? Looking at the map, are there some classes that are being confused all the time that are like water or ag?
I think I identified the water. I think that's where the confusion might be. That's why in the recommendation I'm saying that I would have to add some NDWI indices to it to see how the model perform. Yeah.
Mm-hmm.
Yeah.
And then my last question, actually I'll pause here. Anyone else have any more questions? I saw some hands fly up. I'll pause real quick.
Andrea had one in the chat, Tim.
Okay. Andrea.
What's the sign? Yeah, it's the sign.
Same question.
Same question. For thinking about next steps with your work, you talked a little bit about relating to the greenhouse gases and sort of making not only the classification valuable, but the subsequent products that you could derive from it. But also thinking about the scale. Have you explored using this model for extrapolating and going out beyond your red region of interest? What is that's kind of a broad question, but how do you think that model could perform? Because the urban forestry, that it doesn't just stop at that political boundary, right? There's still sort of that confluence right there. So what are your thoughts about scaling your model?
Yeah, I think it's very possible to scale the model with access to the right resources because using the cloud AI is, you need to make some payments before you can have access to the prediction. So once all those things are put in place, I should be able to upscale this work to other parts of the country. Yeah.
That's wonderful. Yeah, I was going to ask the cost question because going through that process, it can take money, and that's everyone who's on this call who's kind of dabbling with this technology. It's one of the things that eventually you'll run into, right?
So one thing I did was that I had already signed up for the 1-year trial, and so I was able to use that for this analysis. So once that 1 year is over, then maybe I'll have to fall on CVS resources for further analysis. Yeah.
Yeah, and on that point, I think for some of the folks who are maybe newer, we've had resources in the past that we've been able to get from Google to do some prototyping. So, hey, I say we keep getting some good ideas and let's keep the train rolling. Well, great.
Thank you.
Yeah, any other questions on the line?
So one more, maybe another question about a comment. Tim, you mentioned about we can use the keyword to maybe try to test avoid the overfitting. That's a great suggestion. Maybe another thing is you use a deep neural network. So maybe use some more traditional model like random forest.
Okay.
Because from what I know, random forest is pretty good at overcoming the overfitting. because they can build many trees, so they will figure out the overfitting by themselves. So I think it's a good comparison. If you want to publish I don't know you have whether publish a paper now. If you want to publish, you add that part. I think it will be a plus for the paper. Yeah.
All right. Thank you so much for that.
Thank you for your great work.
Thank you.
Yeah, I could imagine the first response from a reviewer is, "What's the baseline to a random forest?" Right?
Yeah. Absolutely.
Hey, I had a quick question, Abena, and this is I just thought about it when Tim was asking about scaling it up.
Mm-hmm.
I remember on one of your slides for the background, you said that, I don't know if it was just Baton Rouge proper or the state of Louisiana had a lot of like commercial logging as part of its economy. Was that correct? Did I have that right?
Commercial logging.
Like timber products.
Oh
like trees for
yeah.
So I wonder how to address that and make sure you're like separating out like commercial forests that kind of get chopped down every few decades or something.
Okay. So that will mean that I have to incorporate like a forest mask to cater for that in the final product.
Yeah.
Yeah.
Yeah. Do you have maybe like some vector data on like commercial logging areas or something like that?
Yeah.
So maybe like a post-processing step.
Thanks for that.
Cool.
Well, wonderful. Any other questions? Well, I'll just take a moment and say thank you so much for this fantastic presentation. We're so happy to have you come and give another talk. I think, again, this is like your third talk. You're always welcome to give presentations in this group. And I know you're busy with all your NASA harvest work, so thank you for taking the time. And I'll just give a round of applause.
Thank you all too for the opportunity. I'm grateful.
Well, wonderful.